Now that we have a good understanding of Boolean expressions and relational operators, we can look at another aspect of C control flow, namely loops. Firstly, it's good to define what a loop actually is. This is for people who have never programmed before. A loop is a way of controlling program flow. In other words, in the same way that an if statement could render certain parts of the code optional, the loop is a construct that renders certain parts of the code repeatable. In other words, a piece of code can be repeated over and over in exactly the same or a very similar fashion until the desired outcome is achieved. Loops and if statements are not completely unrelated. They both use the same conditions. Remember I talked about conditions. That's the bit inside the brackets, inside the round brackets of the if statement. That's the condition, the Boolean expression, the true-false bit. Loops use exactly the same constructs. And there are two types of loops. Firstly, there are loops where it is known at the time when the loop starts how many times through the loop the code will execute. What does that mean? Well, it means that imagine a program is running, and imagine the program is executing line by line until it gets to the beginning of a loop. Now, at that point, the program may or may not know how many times through the loop the program is going to execute. That gives us the two types of loops. So, loops where you do know and loops where you don't know how many times through the loop you're going to run. And I'm not talking about whether you know or don't know at the time that you write the program. I'm talking about at the time when you run the program. I think an example is in order. Imagine a program that counts all the numbers and adds up all the numbers from 1 to 1,000. Now it is quite clear at the time that the program is run, or even at the time that the program is compiled, how many times through the loop you're going to go. You're going to do 1,000 additions, so you're probably going to go through the loop 1,000 times. But you might say, what if the number of times through the loop is read in from the keyboard? What if you ask the user how many times they'd like to run through the loop? Okay, that's a good example. Let's say you do ask that question, you get back the answer 50, and then immediately after that you start the loop. Now, at the time when the loop starts, you do know that it is going to be 50. So both of those examples that I just gave, the 1,000 and the 50, are both examples of you do know how many times through the loop you're going to run. So an example of when you don't know is, let's say, count the number of lines of text in a file. You open up the file and you don't know how big the file is. You just start reading through the file line by line until you get to the end. Until you get to the end. That's the important phrase here. Is that end of the file going to be 2 lines away or 2 million lines away? You don't know. You could probably go and find out, but it's probably not necessary because you can just keep walking down through the file until you get to the end. When you get to the end, you stop. Now, you don't know how many times you're going to go through the loop, whether it be 2 or 10 or a million. You simply don't know at the time that you start the loop. Like I said, there's a way of finding out, but you don't need to do it. You don't bother doing it because it's just a waste of time. I'll give you another example. Let's say you are sitting there reading a line of text from the keyboard, and you're asking the user to enter a number in the range of 50 to 100, and they keep entering wrong data. They keep entering 20 or 2,000 or the word Fred or a semicolon. They keep entering things that are not numbers in the range 50 to 100. And so you have to keep saying to them, that is an error. Please try again. That is an error. You need to enter a number between 50 and 100. And you can keep going around and around and around as long as the user doesn't get it right. Now, at the time that you start the loop, you don't know how many times it's going to take for the user to get it right. You simply don't know. You have to wait until the user does get it right. Now that might be the very first go, or it might be a particularly stupid user and it might take them 100 times to get it right. So that is the other type of loop, the loop where you don't know at the point that you start the loop how many times you're going to end up having to go through the loop. So we have two types of loops. Now these two types of loops are not just the two types of loops that you find in C. You find these loops in virtually every programming language. This is not exclusive to C. What is exclusive to C, obviously, is the implementation of these loops. How do you do those loops? So now I'm going to mention the two actual keywords that are used in C to denote these two types of loops. Now, this is not a rule. This is just a guideline. This is just a usually. This is just a probably. For loops where you do know how many times you're going to go through, you typically use a for loop. For loops when you don't know, you typically use a while loop. For loop, while loop. You'll see those in a moment. Now, as I said, that's not a rule. You can use while loops even when you do know how many times you're going to go through the loop, and you can even use for loops when you don't know, although it's just not common. We'll look at both for loops and while loops next. Finally, before we go and talk about those types of loops, I want to make sure you all know how to avoid infinite loops. Firstly, I better tell you what an infinite loop is. An infinite loop is a loop where the loop starts and there is no valid condition to cause it to stop. For example, you might be in a loop counting up to 1,000, from, let's say, 1 to 1,000. And your condition of exiting may be when, let's say, a certain number x equals 10. That would be kind of silly, considering that you're trying to count to 1,000, but your counter may be going from 1 all the way up to 1,000, but x may have nothing to do with your counter. X may be set to 5 before you start the loop, and the loop might be set up such that it finishes whenever x becomes equal to 10. But there may be nothing in the loop that changes x from 5 to any other value. I hope that was clear, because what would happen in that situation would be that the loop would never end. It would go on counting up until it got to 1,000, and it would probably keep going up to 10,000 and end up wrapping around to negative numbers, but that's a function of integers that you don't need to really know about at this particular point. The example I just gave you is an extremely simple example. It's where the loop counter has got nothing to do with the loop condition. And that is one type of infinite loop. But there are many others, and they all fall into the general category of infinite loops. In other words, loops that start but never stop. And when they do never stop, then what you end up with is your program just simply goes away. It seems to stop responding. It is still responding, of course. It's going through its loop as fast as a computer can go. So it could be that your CPU is being completely used up by the program that's just executing as fast as it can all the steps involved in the loop. So it may be that the program is not doing nothing as it seems. It may be that the program is doing things as fast as it can, but to you, it looks like it's doing nothing. It looks like it's not responding in any way at all. And so you assume the program is hung, and if you can, you kill it, and you start it again. And this time you try and avoid the infinite loop, or you recode it such that the infinite loop can't possibly happen. It's a common programming bug, and every programmer has written infinite loops in their life. They all know what they look like. If you've never written an infinite loop, I suggest that you've never actually been a programmer. Anyway, enough of that. Let's go and look at our first type of loop, the simplest type of loop, the while loop.